welcome back to this channel. In this video, we are going to focus on the mechanism of electrophilic addition. Okay, even though we know that there are 5 reagents that can consider undergo electrophilic addition when react with the alkenes. However, according to the learning objective I, we only need to focus on the mechanism for the electrophilic addition for G4 and G5, which is when the alkene react with hydrogen halide and also acidify water. Okay, according to the Markovnikov rules, we know that the bond between hydrogen and Br will be breakdown and the hydrogen is partially positive. Therefore, it will attach to the carbon with more hydrogen. Okay, and form 2-bromopropane when propene react with HBr. So like in what we learned in chapter alkane, when the question asks us to write for the mechanism, normally we only focus on the major product. Okay, so now we go to the step 1 of mechanism. Attack of pi bond on electrophile to form carbon-cation ion. Since carbon-cation ion is produced, then we have to check is it rearrangement occur or no. Okay, from the term pi bond on electrophile, so you can see that the arrow will come from the pi bond and then goes to the electrophile. In this case, is hydrogen. Then the bond between hydrogen and Br will break down and both electrons will gain by the bromine. So and then now once the carbon double bond break down and then form a new single bond first, which the hydrogen electrophile attached to the carbon with more hydrogen. Here I have 2 hydrogen. However, the carbon with less hydrogen will become carbon-cation ion. And then now we need to classify this carbon-cation ion. This carbon-cation ion is secondary carbon-cation ion. If you shift the positive charge with the hydrogen at the left-hand side here, it will become primary. If you shift the positive charge with the hydrogen at the right-hand side carbon, it also will maintain as primary. Therefore, in this case, no rearrangement is occur because secondary carbon-cation ion is more stable. Okay, so this is not needed, so I will erase it. Okay, then now we complete with the second step. So second step mentioned here is nucleophile attack carbon-cation ion. So the nucleophile is the substance with the negative charge, which means it's the Br negative. So the arrow will from the Br negative to carbon-cation ion, the carbon with the positive charge here. Then the product 2-bromopropane is formed. So very simple. For the mechanism of hydrohalogenation, it only involves two steps of mechanism. Now let's proceed with tutorial question number 9D. Question 9A until 9C we already discussed in the previous video. So write the mechanism for the above formation 2-methylpropene and react with hydrogen bromide. Okay, so if you still remember in step B we already write the equation, so we rewrite again. Propene 3 carbon, so means that double bond attached in between first and second carbon. So second carbon have methyl group, so left hand side here have 1 and 2 more hydrogen, and then second carbon already have 4 bonds, and then the third carbon from the left hand side here still need another 3 bonds, and then react with HBr. So will produce, so as we know, hydrogen is partially positive, which is the electrophile, will attach to the carbon with more hydrogen, which I mark star over here. So it will become CH3 and then Br, CH3 and CH3, two bromo. The name of this product is 2-bromo 2-methyl propane. Okay, so now we focus on the mechanism. Step 1, as we know, attack of pi bond on electrophile. Okay, I just write the short form. So you just draw out the propene and then the bond between the hydrogen and Br. So attack of pi bond on electrophile. So make the hydrogen and Br has different electronegativity, so the bond will break down heterolytic and the bromine will gain the electron, both electron. So will become CH3 carbocation ion and then CH3. So this is the tertiary carbocation ion, which is the most stable step, so we no need to consider rearrangement. Okay, and then don't forget we still have another side product. When the bond between hydrogen and Br is broken, so we still have another Br negative. So then now we can go to step 2. Step 2 will be attack of nucleophile on carbocation ion. Okay, so basically we write again CH3 positive, CH3 plus Br negative. Okay, so now this time the arrow is from Br negative to the carbon, and then we'll produce 2-bromo 2-methyl propene. Okay, based on these two mechanisms, basically we can see there is a similarity. You can see that the arrow basically is always come out from high electron density to the less electron density. Okay, for example, Br negative consider has high electron density because it is negatively charged, and then the movement of, like we mentioned before, the arrow is show the movement of the electron. So it means that it will move from the high electron density atom to the less electron density atom. So this is the working step for the mechanism of the reaction between alkene and hydrogen halide. Okay, you can refer to ChemFriend question number 7 and number 11. You will find that basically the question asked is quite similar, only the structure given will be different. Let's go through the question. 2-methyl propene react with hydrogen chloride. Okay, so just now the tutorial question is hydrogen bromide, so this is hydrogen chloride. Then you need to draw the structure, state the type of reaction, so definitely is electrophilic addition, and then you have to show the mechanism. Let's see question 11. 3-methyl-2-pentene react with hydrogen bromide to produce P. So when you look at the question 7 and 11, they are quite similar. Only every time they will use different alkene and also maybe different reagent. Like this one is hydrogen chloride and then another one is hydrogen bromide. Okay, so similar part as well, they ask us to give the type of reaction and then give the structure for the product and show a complete mechanism for the major product. So if you refer to the tutorial question number 9, it is also quite similar with the things that asked in question 7 and 11. So just a reminder for every one of you. Normally for the organic chemistry, the question is quite similar. Only the product and the reagent given will be slightly different. So you can try these two questions and then we will discuss during the tutorial time. Okay, now we look at the mechanism for another reaction, which is the reaction between alkene with the acidified water. Okay, so in the step 1, basically we call it protonation to form carbocation ion. Okay, so but basically also the arrow, the first arrow, still from the double bond and then attack the hydrogen of the H3O plus. Okay, why here we are showing H3O plus? Because basically we consider H2O is a neutral when with the acidic condition H plus, so this structure will become H3O plus. So the acid in this case is plays the role as the catalyst, like in the dehydration of alcohol to form alkene. Okay, so this is the first arrow that you're going to draw. And then because the hydrogen need to break down the bond with the oxygen, okay, the hydrogen need to break down the bond with this oxygen. So as we know, hydrogen and oxygen is more electronegative than hydrogen. Okay, so that's why the bond will be heterolytic and both electrons will gain by the oxygen. So therefore you will notice again we need to give the hydrogen attached to the carbon with more hydrogen. Okay, so you will see that the hydrogen is attached here and then this is the carbocation ion. So this carbocation ion is secondary carbocation ion. So since the bond is break and then since the bond is break and the electron gained by the oxygen, so now oxygen going to have 2 lone pair electron and left another 2 hydrogen, so it will become H2O. Okay, so next one again, once we already know this is secondary carbocation ion, we need to consider is there any rearrangement possible. So when we compare to here, one of the methyl group from here will shift with the positive sign here. So in this case, because the methyl group is shift with the positive charge of the carbocation ion, so because it is next to each other, so we call 1, 2. And then which one is shift with the positive charge is the methyl. So this rearrangement will be known as 1, 2 methyl shift. So after changing, so you will notice that this carbocation ion now is tertiary carbocation ion, which is more stable if compared to secondary carbocation ion. Okay, we will proceed to step number 2, attack of nucleophile. So in this case, the nucleophile is referred to the water and then on the carbocation ion. So the lone pair electron, so if possible, the arrow better nearer to the lone pair electron here. Again, it's from the lone pair electron to the carbocation ion. Okay, so and then the lone pair electron will form one bond with the carbon and then only left one pair of lone pair electron, and hence now the oxygen will become positively charged. Okay, so next step 3 is deprotonation. As we know, we are going to remove H plus. So how the H plus will be going to remove? Also from the nucleophile, which is the water, play the role, move the electron, the lone pair electron, move and give to the hydrogen. And then the bond between hydrogen and oxygen will break heterolytic and oxygen will gain the electron. Therefore, now the oxygen here basically will have 2 lone pair electron and then left only 1 hydrogen. So one of the H plus combined with the H2O here will become H3O plus. So again, we can prove that the acidic condition, the role of the acid in this hydration of alkene is as the catalyst, because end of the mechanism or end of the reaction, the acid is formed back. So in this video, we already discussed 2 mechanisms. One is alkene react with the HBr, and then another one is alkene react with the acidified water. So the mechanism looks similar, but there is a bit different. So maybe you are the one who going to do your own summary and look at what's the difference between these 2 mechanisms and their difference. So that's all for this video and related about the mechanism. of the electrophilic addition of alkene. So in next video, we are going to learn about the reaction of alkene with the ozone and also strong oxidizing agent KMnO4. Okay, so if you think this video can help you to learn better about the mechanism, please share with your friends and see you in the next video again. Bye bye.